Chapter 5 is a geometry chapter, and the first lesson deals with angle relationships. So, first of all, you need to know what an angle is. And it's an angle, not an angel, so be conscious of the spelling. It's A-N-G-L-E, not E-L. And the angle symbol is right here. It looks like a squished sort of a less than symbol, or not quite as squished as a less than symbol. And it's formed by two rays, which are arrows, their sides, with a common endpoint called the vertex. So here we've got the ray YZ and the ray YX. They come together at vertex Y and they form an angle. Notice at the ends of the angles you do have the arrows because they're formed by rays. You can name the angle in a bunch of different ways. If there's a number within it, you can just name it angle 1. There's only one angle with vertex Y here, so we can call this angle Y. Or we can use the three letters. The vertex has to go in the middle though. So we can call this angle XYZ or angle ZYX. Angles are measured in degrees, which is a little tiny circle up here. And there's 360 degrees in a circle. So 1 degree is 1/360th of a circle. We're going to look at 6 different types of angles right now. And the first one is this cute little angle down here. Excuse me. And this is an angle that's greater than 0 degrees, but less than 90 degrees. And this is called an acute angle. So it's greater than 0, but it's less than 90. This angle we've been dealing with, especially in the last chapter when we had the Pythagorean theorem. This is exactly 90 degrees, and it's called a right angle. In a right angle, they will put a little square in the corner indicating where the right angle is, where the 90 degrees is. Then we have an angle that's greater than 90, but it's less than 180. So greater than 90, less than 180, and that's called an obtuse angle. An obtuse angle. Next, we have an angle that makes a straight line. A straight line has 180 degrees, and this is called a straight angle because it opens up to form a straight line. Here we have two angles together. They're coming at a right angle. 65 plus 25 equals 90, so it's a right angle. And these are called complementary angles. Complementary angles, the key here is it's two angles whose measures add to 90. You could have 3, 4, 5 angles that when you add them all up they equal 90, but we don't call them complementary. Complementary are two angles whose measures equal or add up to 90 degrees. They don't have to be side by side. I could have a 60-degree angle over here and a 30-degree angle over here, and together they add to 90 degrees. Next, we have these two angles. Together they form a straight angle, so they form 180 degrees. 65 and 115 is 180. And these are called supplementary angles. Oops. Supplementary angles. And again, it's two angles whose measures add to 180 degrees. All right, now we're going to go ahead and classify some angles. So here they're asking us to look at this diagram, and there's a slew of angles around here, and we need to pick out a right angle. Well, there's a lot of right angles here, but I'm going to go for the most obvious one. It's labeled at 90 degrees. And I cannot just now call this angle X. And you don't want to randomly put your own number in. You need to use whatever the diagram gives you. So I could call this angle NXP or angle PXN. But again, I can't just call it X because I have an MXS, and that's not the angle I'm looking for. And I have other angles with X as a vertex. So I'll say angle PXN. PXN. Now I need to name two acute angles. Remember, an acute angle is greater than 0 but less than 90. And I can see right here that these two are greater than 0 but less than 90. So MXS and RXS. And again, it's not wrong if I would have called it SXR. It's the same angle. Notice I am putting the angle symbol in front because if I don't put the angle symbol in front, then it's not truly talking about the angle. I need two obtuse angles. Obtuse angles, remember, are greater than 90 but less than 180. So they're not blatantly sort of out here. I have to search for them. If I look right here, this angle is greater than 90 because MXN is 90, and then I'm going to add a little acute angle onto it. And I'm going to call this angle NXS. And I have another one right here. And these are not the only two, but these are the two that I'm going to show you. And this is SXP. Don't forget your angle symbol. Now we want a pair of complementary angles. Remember, complementary angles are two angles that add to 90. And I can see here that this is forming 90 degrees. And the way that I know that really is that NXP and MXN form a straight angle. So these are both 90. And if that's the case, then NXM and MXR also form a straight angle. Well, these two angles right here form MXR. So it's MXS and RXS. Happens to be the two acute angles that we have in the diagram. And then they want three pairs of supplementary angles. Remember, supplementaries add to 180. So if I look at this line right here, I can find two angles that make it up. So this angle makes it up along with this angle. So those are actually supplementary. MXN and RXM. I'll put a little semicolon here to show that these two go together, and now the next two are going to go together. And here, this is a straight angle that's made up of this angle and this angle. So MXR, whoops, I don't want that, and PXR, and I've used these two, and I'm again looking for supplementary angles. Well, I can still look at this line right here, this line, but I can use these angles instead. So these two angles, MXN and NXP. Alright, now we get to put some numbers in here. So it says use the diagram to find each angle. If I'm given a diagram and an angle measurement, I put it right into the diagram. And they're asking us to find the measure of angle 3. Well, I know angle 2 and angle 3 make a straight angle, and straight angles are supplementary. They add up to 180. Or a straight angle itself, sorry, is 180 degrees. So I can take 180 and subtract the 75, and that gives me 105 degrees. So the measure of angle 3 equals 105, and it's proper to put M and then angle. So this is 105 degrees. Now they want us to find the measure of angle 4. Well, again, they're showing us here that angle 3 and angle 4, they make up this straight angle. So they must also add to 180. So if I take the 180 and subtract now the 105, I get 75 degrees. So the measure of angle 4 equals 75 degrees. And I'm sure you already have guessed that angle 1 is also 105. So we had 75 degrees here, 105 degrees, 75 degrees, 105 degrees. Now I don't want you just fast forwarding and skipping over these important angle types, so let's look at these. In example 2, there's examples of adjacent angles and vertical angles, and these are special because of their positions. So first let's look at adjacent angles. They have a common vertex and they share a side. So if I just randomly choose this side, the two angles that share that side are angle 2 and angle 1. Notice that angle 1 and angle 2, though, do not share any common interior points. Nothing here, nothing here. They don't have any points in common. They share a vertex and a side. So we can come up with another pair of adjacent angles. If I just randomly pick this point right here, or sorry, this side, then it's angle 1 and 4. They share this vertex, they share this side, but that's all they share. So those are adjacent. Next, we have definition of congruent angles. Congruent angles have the same measure. We've gone over congruency before. So here we had angle 1 was 105 degrees, and so was angle, well, 3 and 1 were both 105 degrees. So we say that angle 1 is congruent to angle 3. This is the symbol for congruent. Congruent. They have the same measure. And then 2 and 4 were also congruent. They were both 75 degrees. And lastly, we have vertical angles. They're not adjacent, so they don't share a side, but they do share a vertex. So if we look at this, here's a common vertex, and they don't share a side. So if I look at angle 3, it shares a vertex with 4 and 2, but they also share sides. So angle 1 has to be vertical to angle 3. And you can see here in the picture also, angle 2 and 4 are vertical. They only share a vertex. And it just so happens vertical angles are congruent. Vertical angles are congruent. I always think that vertical angles, they form a V, whether it's up or down or sideways or diagonally, but they do form a V. All right, use the diagram to find each angle measure. So measure of angle 2 is 110 degrees. They want angle 4. Well, they share a vertex only, so they're vertical, so the measure of angle 4 is congruent. So it's also 110 degrees. Next, angle 1 is n degrees, so I'll just put a little n degrees in there. I know that angle 1, if it's n degrees, we can figure it out. It says find each angle measure, so we can figure it out. Angle 2 is 110. 1 and 2 are adjacent, but more than that, they are straight angles, so they're supplementary. So they add to 180. So if I subtract, angle 1 is 70 degrees. Well, look at this. 1 and 3 are vertical, so angle 3 is also 70 degrees. An artist is designing a section of a stained glass window. Based on the diagram, what should be the measure of angle ECF? So we're looking at ECF, not that full right angle, but this part of the right angle. This is an acute angle, less than 90 degrees, but more than 0. But I have been given this 32 degrees, and they wouldn't give it to me if I didn't need it. So if I look at that vertex, that's the vertex of it. Right here's the angle. Right here is the vertical angle. So I know that DCE is also 32 degrees. And these two angles, DCE and ECF, are complementary. So I know that together, and I know they're complementary because I've got the right angle symbol there buried, but I know that together they add to 90 degrees. So this gives me a 58 degrees for this angle ECF. All right, last one. Here we have a diagram showing the intersection of 3 roadways on a map. Based on the diagram, what should be the measure of angle ECD? And they give us that angle BCE is 30. Well, the vertical angle to 30, or this angle, is right here. So I know that this angle is 30 degrees. That's not part of the angle I'm looking for. However, I do have a right angle here, so these are complements. So I'll take 90, subtract 30. So this is 60 degrees up here. And I know that this angle was 90 degrees because it forms a straight angle. And I'm looking now for this angle, and it's made up of the 90 and the 60. So it's 150 degrees. So the measure of angle ECD is 150 degrees. All right, here is your assignment if you want to start it early. You don't have to, but if you have time, might as well. And yes, I know I could have done 29 to 31, but I didn't think about it and I just listed them all out. So if you want it, there it is.